The morning of December 11th brought more than silence from the sky. It brought motion, subtle, structured, and unmistakable. For weeks, 3i Atlas had followed a strangely stable outbound trajectory, until now. In a series of high-frequency observations from ground and space-based telescopes, the object suddenly lit up. But not from solar flare impact, and not from chaotic sublimation. This was different. This was activation. From rhythmic jet pulses to directional shifts in reflectivity, everything about its behaviour suggests coordination. Whether natural or not, 3i Atlas is no longer dormant. It is now doing something, and as it edges closer to Earth, the timing could not be more unsettling. This isn't just about tail dynamics or coma shape anymore. It's about something that behaves as if it's preparing for something, as if proximity matters, as if Earth matters. Let's begin. In the early hours of December 11th, something changed. For days, 3i Atlas had been moving with quiet consistency, its light curve flat, its thermal readings stable. Astronomers expected the silence to continue, a cold, outbound path following its perihelion encounter with the Sun. But then came the spike. At exactly 0312 UTC, a sharp increase in visual magnitude was registered simultaneously by several observation platforms across the globe. From Chile's Paranal Observatory to the Canada-France-Hawaii telescope, instruments detected the same thing, a brief but unmistakable brightening event. Not a slow fade-in, not a lingering flare, but a precise and contained jump in luminosity. The change was sudden, lasting under 3 minutes, and then subsiding as if nothing had happened. At first, astronomers questioned the readings. They checked for satellite interference, looked into cosmic ray strikes, and reviewed the data logs for software anomalies. But nothing pointed to instrumentation failure. The signal had come from the object itself, and as more observatories confirmed the same pattern, a realization began to settle over the scientific community. 3i Atlas had just done something intentional, or at least something that didn't match any natural expectation. Unlike previous outbursts observed in comets, which often produce chaotic clouds of gas and dust, this brightening came with no visible fragmentation, no debris, no plume. The coma remained symmetrical, the tail didn't expand. In fact, the overall structure of the object stayed remarkably clean. The increase in brightness wasn't associated with shedding, it was associated with reflection. Photometric analysis revealed a shift in surface albedo, the object's reflectivity. That change, brief and targeted, was strong enough to elevate the total brightness by nearly 20% in under 180 seconds. Not because of new material being emitted, but because the existing surface had changed its interaction with sunlight. That subtle detail changed everything. This wasn't a thermal outburst caused by surface heating. This wasn't the result of a volatile pocket exploding into space. This was something quieter, controlled, like a reflective panel turning toward the sun, like a surface adjusting its angle. The increase in brightness came too fast and disappeared too precisely to match the randomness of traditional comet behavior. Some compared it to a satellite flare, when the angle of a spacecraft's reflective body aligns just perfectly with Earth, causing a brief glint of intense brightness. But 3i Atlas is not in orbit. It's travelling through the solar system on an outbound hyperbolic path, not looping Earth. For a flare-like event to occur from such a body, it would require geometry, symmetry, something structural enough to rotate in a stable manner and hold orientation long enough to generate that kind of signal. That's not what comets do. That's not what loose, dusty, irregular rocks from interstellar space are supposed to be capable of. Yet the data shows no evidence of disruption. No crumbling, no chaotic venting, just a clean mathematical spike, and then silence. Observers at the Subaru telescope described it as a mirror turning once then stopping. The phrase repeated across forums and research chats. A mirror. Not because it was literally made of glass or alloy, but because of the way it behaved with light. Smoothly, cleanly, almost artificially. That single brightening event now serves as the ignition point for everything that follows. Because once it became clear that 3i Atlas could modulate light, not by emitting it, but by controlling how it reflects, everything else had to be re-evaluated. From its jets to its tail, from its internal heat to its trajectory. The silence had broken, and not with an explosion, but with a glint, a signal in reflection. And that glint, brief as it was, changed the entire shape of the story. In the hours following the sudden brightening, instruments tuned to a different kind of light picked up something just as unusual. Not in the visible range this time, but deep in the spectrum, beyond what the eye can see, where composition is revealed not through shape or colour, but through frequency. Infrared and ultraviolet telescopes locked onto 3i Atlas immediately after the spike in magnitude. What they found wasn't a cloud of new material, nor a flare of volatile gas. It was subtler than that, more precise, a shift, not in brightness, but in the spectral lines themselves, a drift. The phenomenon, now referred to among astronomers as a spectral glide, wasn't loud, it wasn't dramatic. But it was deeply telling. Over a span of just under 9 minutes, the reflected light coming off 3i Atlas began to bend, ever so slightly towards shorter wavelengths. The object's spectral fingerprint, normally stable and consistent with dust-dominated reflection, began to change. And that change wasn't chaotic. In natural bodies like comets or asteroids, spectral shifts often follow predictable rules. As a surface heats, it releases volatiles, molecules like carbon monoxide, carbon dioxide, or water vapor, that appear as identifiable absorption or emission lines. But here, there were no new lines, no additional volatiles, no sharp increases in carbon-bearing molecules. Instead, what occurred was a continuous, almost fluid migration of the existing reflectance pattern. It looked like the surface was altering, not chemically but optically, as though the material itself had changed the way it responded to light. That raised new questions. Why would the reflected signature of a passive outbound object start trending toward shorter wavelengths, toward the blue end of the spectrum without an increase in heat, gas, or debris? Shorter wavelengths imply either a higher energy state or a smoother, more structured surface. Neither should be happening here, and yet, both appeared to be. The James Webb Space Telescope's near-spec instrument recorded a flattening of certain thermal gradients, while ESA's solar orbiter reported a matching ultraviolet intensification on the sunward side of the object. This convergence of data led to a growing theory, one that suggested 3i Atlas had not just flared. It had changed, not disintegrated, not vented, changed. The surface, some proposed, had reoriented or transformed in such a way that its interaction with solar photons had become more efficient. It now reflected more energy back into space, but at different frequencies. The implications were subtle, but enormous. This wasn't a random outburst, it was a systemic shift. Amateur radio astronomers added another strange detail. During the same time frame as the spectral drift, the background thermal noise from the object increased slightly in narrow bands, not enough to register as heat, but enough to suggest electrical activity, perhaps a reorganization of surface charge, or a rebalancing of material properties after a rotational move, and then silence again. The spectrum settled, the drift ceased. The object returned to its baseline. This spectral anomaly, quiet as it was, marked a turning point. The data no longer pointed to a conventional comet. Because spectral shifts like this don't occur without cause, they require change at the atomic level, at the material level. It was as if 3i Atlas had adjusted its surface for a reason, not for survival, not in response to a flare, but proactively. To what end, no one could say. And yet across every observatory monitoring the object, one word started appearing in internal reports, a word rarely used in planetary science: responsive. That is what shook the analysts most. Not just that the object was changing, but that it seemed to know when. Hours after the spectral drift, another anomaly emerged, this time visible even through mid-tier amateur telescopes. Jets. Not just ordinary plumes of escaping gas, but structured, consistent, and above all, directional. For days, 3i Atlas had shown signs of mild outgassing, as expected from any interstellar object exposed to solar radiation. But these emissions had been faint and evenly distributed. Standard behavior. That changed abruptly on the morning of December 11th. Images from the Subaru telescope stacked across a 4-minute capture window revealed a narrow, highly focused stream of material extending from the nucleus, not radiating outward randomly, but projected along a tight vector. The jet was thin, nearly filament-like, and curved slightly as it moved through the vacuum, not from chaotic turbulence, but from interaction with the directional force. This was not sublimation from a dusty surface. This was controlled emission, and it wasn't alone. Roughly 3 hours later, a second jet appeared, this one trailing off the opposite hemisphere, angled away from the sun but not directly along the tail. It arced to the side, forming a mirrored symmetry. The object now had 2 distinct measurable jets, both consistent in strength and duration, and neither aligned with traditional thermal expectations. Normally, cometary jets erupt from irregular patches where sunlight heats buried volatiles, releasing plumes in unpredictable bursts. They flicker, they flare, they vanish. But these jets from 3I Atlas were continuous, clean, and geometrically spaced. The orientation raised even more questions. The first jet, sunward, defied the standard outgassing model entirely. Material ejected toward the sun goes against the very forces that drive cometary activity. Solar radiation and solar wind should push emissions in the opposite direction. For a jet to point into the solar vector, it would need to be forcibly expelled, with power, with intent. Infrared imaging from the Spitzer network revealed something else. The particles in both jets were unusually uniform in size and speed, not a chaotic mix of dust and gas, but consistent micrograins, moving in tightly clustered lines. This wasn't erosion, this was thrust, and it wasn't just coming from the visible surface. Radio measurements taken simultaneously from Australia's Square Kilometre Array showed a mild electromagnetic disturbance near the base of the forward jet. A low-frequency oscillation, rhythmic, nearly harmonic. It didn't match any known solar emission profile, and it began only when the jet activated. This opens the door to a theory many are still hesitant to speak aloud, that the jets are not random bursts but functional, that 3I Atlas is not being acted upon, but is acting. If that's the case, then the jets aren't just emissions, they're mechanisms, propulsion perhaps, or stabilization, something more than thermal escape. And there's another detail, no precession. Even under asymmetric outgassing, comets wobble, they drift. Their rotation becomes uneven, but after these jets activated, no wobble was recorded. In fact, the object's rotational light curve became smoother, more stable, as if the jets weren't disrupting motion but correcting it. Imagine a spacecraft using microthrusters to maintain orientation. Small, precise emissions that push it back into balance. That's what this looked like. And that idea, the image of an interstellar body self-correcting its course with active jets, is where science meets discomfort. Because while natural comets do jet, they don't steer. And yet, on the morning of December 11th, 3I Atlas did. 2 jets. Balanced, geometric, persistent. And if those jets are not random, then neither is what comes next. As the directional jets settled into their steady rhythm, yet another anomaly made its presence known. This time, a familiar shape returning to the sky. It wasn't a new structure. In fact, it had been observed before, briefly, then dismissed by many as a trick of light and angle. But on December 11th, the antitail came back, and this time, it refused to be ignored. Antitails are among the rarest and most misunderstood features in comet science. Unlike standard tails, which are pushed away from the sun by radiation pressure and solar wind, antitails appear to point in the wrong direction, back toward the sun itself. Traditionally, they're not real structures. They're considered optical illusions, caused by forward scattered dust particles that lie in the orbital plane of the comet, forming a thin trail that Earth just happens to intersect visually from a particular angle. But that explanation, while usually sufficient, didn't hold up this time, because what reappeared behind 3I Atlas was not faint, not static, and not dependent on Earth's orbital position. This anti-tail was active. High-resolution time-lapse imagery from the Atacama Desert showed the structure forming in real time. Not just material left behind in the object's orbital plane, but a narrow, coherent stream of particles arcing directly sunward. And more unsettlingly, the brightness of the anti-tail increased during the same period when the primary jets activated. The emissions were synchronized. Even more strange, the anti-tail cast a detectable polarization signal, meaning it wasn't just a ghostly haze but a real, structured beam of matter interacting with solar radiation in measurable ways, and its direction held firm, even as the viewing geometry from Earth shifted slightly. The tail didn't blur, didn't fade, it pointed straight at the sun, hour after hour. This consistency makes the optical illusion theory much harder to support. Telescopes in Poland, Canada, and Chile, all at slightly different longitudes and latitudes, confirmed the same angular offset. The anti-tail wasn't a mirage. It was material, moving with direction, structure, and possibly purpose. But why would a comet eject mass toward the sun? No known natural mechanism explains this behavior. Comets heat unevenly. Their surfaces vent gases from the sun-facing side, sending particles in the opposite direction. That's why tails always stream away from the sun. Yet here we have the reverse, ejection into the solar vector. The implications are enormous. If 3I Atlas is emitting mass toward the sun, then it's not reacting, it's responding. It's not enduring solar energy, it's engaging with it. One theory proposes a functional propulsion system, a sunward jet acting as a stabilizer or braking force. Another suggests the anti-tail could be reflective debris, intentionally directed to interact with light pressure for thrust or navigation. Either idea moves us far beyond standard comet dynamics. But the most provocative data came from SOHO. As it tracked the region near the sun, SOHO detected a faint light echo in the same vector path as the anti-tail. A backscatter reflection, possibly from dust, possibly from something else. The signal's consistency with prior anti-tail angles suggests that the structure not only persisted but evolved. And then, just before the tail began to fade, something changed. The reflected signal shifted from diffuse to polarized, then dropped off completely, almost as if a switch had been flipped. That word, switch, is what keeps returning in the minds of those watching closely, because natural structures do not turn on and off. They decay, they erode, they scatter. This didn't scatter, this stopped. And in that sudden disappearance, the anti-tail made its strongest statement yet, not as a visual trick but as a feature, a real one. And if it was real, then 3I Atlas isn't just passing through space, it's doing something in it. After the sudden brightening, after the spectral shift, after the jets appeared and the anti-tail returned, you would expect turbulence, chaos, a sharp rise followed by decay, a natural reaction to a system pushed out of equilibrium. But that's not what happened. Instead, 3I Atlas held its light. For nearly 6 consecutive hours on December 11th, the object's visual magnitude stabilized. No more flaring, no decline, no intermittent flicker, just a calm, consistent luminosity, something comets are not known for, especially after violent outgassing events. In fact, brightness stability over that time frame is almost unheard of in cometary physics. Natural bodies don't do this. They flash and fade, they brighten under heat, then dim as the gas disperses. They pulse when volatile pockets rupture and vent, and most importantly, they drift. Light curves from traditional comets show irregular fluctuations caused by rotation, venting, fragmentation, or debris cloud expansion. But in this case, the light curve was flat, smooth, controlled. Multiple observatories confirmed the same behavior. The Mount Lemmon survey in Arizona, La Silla Observatory in Chile, and even smaller independent networks from Italy and Japan all recorded the identical plateau in brightness. No matter the aperture, no matter the angle, the numbers matched. This consistency raised a new kind of question, not just about what was happening, but about what wasn't. Why was the object staying bright, even though all external signs of heating had faded? By mid-morning, solar exposure had begun to decrease. The rotational position of 3I Atlas would have naturally shifted some of its surface into darkness, and yet no dimming occurred. The brightness remained stable across all rotational phases. Some speculated that internal heating could be responsible, that perhaps a massive subsurface layer of volatiles was now sublimating from within, insulated from direct solar input. But infrared readings told a different story. Surface temperature readings from ESA's infrared monitoring program showed no significant thermal increase during this brightness plateau. No heat spike, no radiative plume, just light. And that raised another possibility. What if the brightness wasn't caused by emission at all? What if it was reflection? High albedo materials, surfaces capable of reflecting enormous amounts of light, are rare in space. Ice can do it, but only when fresh. Metals can too, but they're almost never exposed on the surface of a natural object. The James Webb Space Telescope recorded a reflectivity signature, peaking near 90%, a level consistent with polished synthetic surfaces, mirrors, foils, radiative tiles, words that don't belong in comet vocabulary, yet kept appearing in technical memos. If this light was not being emitted from gas, but instead being reflected from surface geometry, that would explain the steadiness. Because reflection doesn't pulse, it doesn't decay, it holds. And that hypothesis began to gain ground, especially when researchers noticed one more detail: phase angle dependence. As Earth's observation angle changed slightly during the morning hours, the object's brightness did not adjust as expected. In fact, it briefly increased as the solar angle narrowed, suggesting specular reflection, not isotropic scattering. In simpler terms, it looked shiny. The light came off the surface like a beam from a smooth shell, not from dust, not from vapour, but from structure. And then, without warning, the brightness began to fall, not sharply, not in panic, but slowly, evenly, predictably, like a lamp being dimmed. And that's the part no one can explain. Why did it hold light for hours? Why did it reflect like a solid engineered surface? Why did it release that light with precision timing? It wasn't the flare that disturbed scientists, it was the calm after. The brightness didn't erupt, it sustained. And in that sustained glow, something deeply uncomet-like revealed itself. This wasn't a dying comet fighting for balance. It was something else, something holding position, holding light, holding steady, until it decided not to. By mid-morning on December 11th, the brightness of 3 Atlas had begun to dim, but what followed next caught astronomers completely off guard. Not because of how bright the object remained, but because of how precise its shape began to appear. The coma, the halo of gas and dust that typically surrounds a comet's nucleus, should be chaotic by nature. It's the product of random venting driven by heat, fractured terrain, and asymmetric outgassing. In most observations, comas are blurred spheres of particle flow, uneven, disordered, organic. But the coma of 3I Atlas was none of those things anymore. At 10:26 UTC, enhanced composite imaging from the Nordic Optical Telescope revealed something subtle but unmistakable: symmetry. The outer perimeter of the coma showed faint, repeating edges, not jagged, not curved, but angular, almost polygonal, a geometric boundary forming inside a structure that should be amorphous. Initial skepticism was high. Dust fields can swirl under solar wind, charge interactions can distort coma shape. Optical artifacts, especially near high-contrast backgrounds, are not uncommon in astronomical photography. But none of those explanations held up. Multiple filters were applied, raw exposures were cross-checked with space-based instruments. And then came confirmation, from the Subaru telescope, from Mount Lemmon, and from ESA's solar orbiter. The pattern held. Not only was it real, it was also rotating, with the same period as the object's known spin. Each time 3I Atlas completed a half rotation, the angular edges of the coma shifted into perfect alignment with its forward vector. Not the tail, the direction of travel. That correlation shook the assumptions of even the most conservative analysts. This wasn't diffusion, it wasn't dust swirl, it was orientation. The angles themselves weren't perfect. Astronomy rarely deals in perfect geometry, but they were consistent enough to suggest a form, 6-sided, faint but stable, a hexagonal glow. Not from the object's nucleus itself, but from the interaction zone between expelled particles and space. The coma was responding to something internal. Researchers began to consider an unfamiliar model. What if the coma wasn't being shaped by external forces, but by boundary conditions? That is, what if the particles being emitted weren't just drifting into vacuum, but passing through structured exit points? A natural comet vents randomly. It erupts from weak spots. But here, the particle distribution followed repeating axes. They traced lines across the coma's edge that didn't scatter or blur over time. And when those lines were plotted across several rotation phases, a pattern emerged, jets synchronized not just to spin but to surface sectors. This kind of structure implies segmentation, a body broken into zones, and that word, zones, raises a possibility rarely considered in comet studies. internal organization. Comets don't have compartments, they don't have panels or vents or radiative symmetry. But 3I Atlas was behaving as though it did, and the coma, the cloud meant to be messy, was displaying an intelligence of form. A few researchers floated alternative theories: magnetic field interactions, electric charge sorting, solar wind interference. But none of those could explain the lockstep rotation. None could account for the geometric consistency. And then, as the coma reached maximum angular clarity, it shifted again. The outer glow tightened, the hexagonal edge faded, and the coma returned to a more circular silhouette. Just like that, the geometry disappeared. It was as if the object had finished what it needed to do, as if the shape had served a purpose and then was no longer necessary. Not a collapse, not a flare, but a transformation, temporary, tactical, precise. This was no longer about whether 3I Atlas was unusual. It was now about why, for 6 full rotations, the space around it formed a shape, and what that shape was meant to do. Just as the geometric coma dissolved back into silence, a new data stream arrived, this time from the infrared and photometric satellites tasked with monitoring thermal behavior. The findings were not subtle, not ambiguous, and not comet-like. For the first time since tracking began, 3I Atlas registered a reflectivity level above 90%. In astronomy, surface reflectivity, or albedo, is a measure of how much sunlight an object bounces back into space. Most comets, composed of dust-coated ice and porous rock, fall somewhere below 10%. Even the brightest icy bodies rarely exceed 30. Reflectivity above 50 is rare. Above 70? Unprecedented. But 90? That number lives in a different category entirely. It belongs to manufactured materials. And yet here it was. A cold, outbound object from interstellar space, reflecting more light than most known natural bodies in the solar system, surpassing even fresh polar ice, exceeding the reflectivity of clouds, approaching levels seen only in foils, polished alloys, and artificial composites. The spike didn't last long, less than an hour. But the readings were confirmed across 5 instruments: NASA's NEOWISE infrared telescope, the Canada-France-Hawaii telescope, the James Webb Space Telescope, and 2 ground-based observatories in Italy and South Africa. The curve held firm. And just like that, another boundary was broken. The reflectivity increase was not just a static rise, it was targeted. Only one hemisphere of 3I Atlas showed the jump, the side facing both the Sun and Earth simultaneously, during the object's brief alignment. The rest remained normal, within previously measured values. It was as if one part of the surface had changed, quickly, deliberately, and then returned to its baseline. But what kind of surface reflects that much sunlight? Natural candidates are limited. Ice, as mentioned, doesn't reflect that well once it's been exposed to vacuum and radiation. Dust, even in ideal conditions, absorbs far more than it reflects. To reach 90% reflectivity, you would need something smooth, something structured, polished nickel, multi-layer insulation, thin film metallic sheeting, in other words, engineering. This wasn't a faint glint or one-off anomaly. This was sustained brightness at levels incompatible with traditional comet composition. And it came immediately after the geometric coma phase, as if the structure revealed in the halo had briefly exposed something beneath it, or activated it. Spectral analysis provided further context. The light wasn't diffused the way it would be if bouncing off a dust field. Instead, it showed strong specular reflection, a mirror-like behavior where light follows clean paths, indicating smoothness at the microscopic level. That smoothness is key. Because rough, naturally weathered surfaces scatter light in many directions, but 3I Atlas sent it back along a narrow vector. This suggests the surface wasn't just reflective, it was flat. Then came the polarimetric data, another unexpected twist. The degree of polarization jumped in tandem with reflectivity, and then vanished just as suddenly. That's not how natural reflections behave. It implies a temporary realignment, either of material, surface texture, or angle. Something moved, something changed, and then silence. The object dimmed again, not sharply, not erratically, but evenly. The reflectivity curve returned to normal, and the telemetry stabilized, but the implications lingered. If a natural object from deep interstellar space can spontaneously develop mirror-like properties, then we must accept that the rules we've used to describe surface physics are incomplete. But if it can't, if 90% reflectivity is as unnatural as it seems, then the light from 3I Atlas wasn't just accidental. It was a signal, not in the radio spectrum, not in code, but in geometry, in brightness, in the language of optics. A mirror in space doesn't speak, it shows. And for 60 full minutes, 3I Atlas showed us something very few things in the universe can: the unmistakable signature of design. Just after the object's surface reflectivity peaked, when 3I Atlas briefly outshone nearly every natural body of its size ever recorded, another shift began. This time, not in brightness, and not in shape, but in chemistry. The spectral signature of carbon, so essential, so foundational to comet behaviour, began to collapse. For weeks, 3I Atlas had shown an unusually strong presence of carbon-based volatiles. Carbon dioxide, carbon monoxide, and trace organic molecules had been consistent features in its infrared and ultraviolet scans. This was one of the key reasons many scientists had continued to argue for a natural origin. The carbon ratio wasn't typical, but it was still within the boundaries of exotic comet chemistry. It supported the idea that this was simply a remnant from another star system, formed in colder regions where carbon-rich ices were more stable. But over the course of just 90 minutes on December 11th, something changed. The carbon lines weakened, first slowly, then quickly, until they were effectively gone. The first observatory to report the drop was the South African Astronomical Observatory, using the SALT spectrograph. At first, they assumed instrument error. Carbon monoxide peaks that had been sharp and measurable only hours earlier were now barely distinguishable from background noise. By the time the telescope recalibrated and confirmed the readings, alerts were already coming in from the Gran Telescopio Canarias and, separately from the James Webb Space Telescope's near-spec array. The data matched. The carbon wasn't just decreasing, it was vanishing, not dispersing, disappearing. Under normal circumstances, this would be explained by a depletion event. Comets lose volatile material all the time. As they near the Sun, they outgas and deplete their reserves. Once the carbon is gone, it's gone. But that's not what was happening here. The collapse in carbon signature didn't follow any known thermal decay curve. It didn't taper. It didn't fade with distance from the Sun. It cut off, as if the supply had been isolated, or the surface that had been emitting it had been sealed. The chemical absence was not subtle. Carbon monoxide absorption lines, typically broad and strong in infrared, fell beneath detectable thresholds. Even the signature bands of simple organics, methyl compounds, CH groups, flattened out entirely. What replaced them was an unusual clarity in the spectral profile. No fog of mixed volatiles, just silence. But there was another strange twist. Water vapour levels remained unchanged. If this had been a natural cooling effect or a chemical exhaustion event, the water signals would have dropped too. But they didn't. In fact, hydroxyl emissions, caused by solar UV breaking apart water molecules, continued at a steady pace. It was as if only the carbon-bearing molecules had been removed, while everything else kept flowing. That doesn't happen naturally. Volatiles sublimate based on depth, solar heating, and surface composition. You can't surgically suppress only the carbon components without affecting everything else, unless something intervenes. One hypothesis emerged quietly in research forums: a phase transition, a restructuring of the outer layers. Perhaps the carbon wasn't destroyed or depleted, but covered, replaced, hidden beneath a material that no longer allowed carbon signatures to escape. And what material would do that? Metallic shielding, regolith crusting, or something we haven't yet seen. The silence from the carbon signature raised a bigger question. Why now? Why would the object suppress its carbon emissions at the same time its surface reflectivity jumped to 90%? Why would it become less comet-like just as it aligned with Earth and the Sun? Unless the carbon wasn't just a byproduct of origin, unless it had been a kind of camouflage, and once the performance was over, the mask came off. By the afternoon of December 11th, 3I Atlas was no longer behaving like a comet. It wasn't fading into the distance, it wasn't shedding dust, and it wasn't slowing down. Instead, it began doing something else entirely, something timed. It began to pulse. The first signs were subtle, just a faint variation in brightness, almost imperceptible against the backdrop of deep space, but the pattern repeated, and then it repeated again. What looked like a brief fluctuation in the light curve wasn't an error. It was an interval. 3 observatories detected it nearly simultaneously: the Lowell Observatory in Arizona, the Taeduk Radio Astronomy Observatory in South Korea, and ESA's Gaia Ground Relay Network. All 3 noticed rhythmic oscillations, small rises and falls in brightness, spaced exactly 48 minutes apart. This was not random fluctuation, not noise. The consistency was mathematically precise. Each pulse was separated by the same duration, with less than 1 second of deviation across multiple observation windows. And the pattern persisted for hours. This immediately ruled out many of the usual suspects. Rotation, for example, would show up as a long-period light curve shift, usually every few hours for cometary bodies, depending on shape and spin. But this wasn't slow, and it wasn't shape-dependent. It was internal. What made the pulses even stranger was their sharpness. Each one began and ended within roughly 15 seconds. A sudden rise in brightness, followed by an equally sudden drop, with no thermal bloom and no dust emission. In essence, a blink. Some described it as a strobe. Others likened it to the rhythmic beacon of a lighthouse, spinning, shining, marking time. But whatever it was, it didn't match any natural cometary activity. No known physical process on a cold interstellar object produces optical pulses this clean. Radio observatories then added another layer. During the exact moments of optical brightening, several low-frequency radio telescopes recorded matching bursts in the megahertz band. Not strong enough to constitute a signal, but consistent enough to eliminate randomness. The pulses were real, and they weren't limited to visible light. And still, they kept going. For 5 cycles, nearly 4 hours, the Roche Atlas maintained its 48-minute interval. Not a second skipped, not a beat missed. Then, without transition, the pulses stopped. No flare, no fade, just silence again. The sudden halt raised more questions than the pulses themselves. If this had been a thermal venting cycle, it would have slowed down as internal pressure decreased. If it had been driven by surface rotation, it would have displayed gradual desynchronization. But none of that happened. It was as if the object had completed a sequence, a program, and then shut it off. Among researchers, this raised a deeply uncomfortable hypothesis: intentional modulation. In natural physics, periodicity emerges from mechanical systems like rotation, orbit, or oscillation. But this was discrete periodicity, not continuous, not decaying. It had a start, a tempo, and a clean stop, like a timer. One theory proposed that the pulses could be a form of internal thermal regulation, venting excess energy through controlled reflection. Another suggested that the object was rotating a highly reflective surface through Earth's view once every 48 minutes. But these explanations required geometry so precise and timing so stable that they bordered on impossible without intervention. And so a new word entered the conversation, quietly, almost reluctantly: transmission. No one is claiming that 3i Atlas is sending a message. There's no decipherable content, no structure in the pulses beyond their rhythm. But the behavior itself, this metronomic, clock-like regularity, is now part of the official data. Because comets do not blink, they fracture, they flare, they fade. But this one did none of those things. It pulsed, and then it stopped. Following the sudden silence of the pulse intervals, telescopes around the world shifted their attention back to the tail of 3i Atlas. For weeks, the tail had been a relatively stable feature, long, narrow, and aligned consistently with solar wind pressure. It exhibited some curvature, some streaming, and the usual turbulence you'd expect from a comet crossing magnetic fields. But on the evening of December 11th, everything changed. The tail became dynamic, not in the chaotic sense of fragmentation or dispersion, but in a structured, adaptive motion that left scientists rechecking every assumption they'd made about the object's behavior so far. The shift began subtly. The Stereo A spacecraft, positioned in heliocentric orbit to monitor solar activity, captured a soft undulation in the tail's alignment. At first, it appeared to be nothing more than a change in solar wind intensity, a common occurrence as objects near the inner solar system. But then, from one frame to the next, The angle of the tail snapped into a new direction, a movement too fast and too precise to be caused by simple plasma flow. Minutes later, ESA's solar orbiter confirmed the change. The tail had reoriented, not wobbled, not curled, reoriented. With a shift of over 15 degrees, the tail pointed toward a region of space far from the expected outflow path, and then, less than an hour later, it shifted again, not gradually, not due to a solar flare, but in a motion that resembled pivoting. That word, pivoting, was what began to unsettle observers, because tails don't pivot, they stream, they follow solar radiation, they curve when pushed, but they don't independently realign. And yet, 3i Atlas was doing exactly that. Even more intriguing was what came next. High-resolution time-lapse imaging from the Lowell Discovery Telescope revealed a pattern forming in the tail's motion. The structure wasn't just turning, it was oscillating. Slow, wave-like bends began rippling across the tail's length at regular intervals, with a repeating cadence that appeared synchronized to the object's earlier pulse cycle. The tail was moving intelligently. Not in the conscious sense, but in a way that mimicked response. It shifted direction with solar flux changes, but ahead of them, almost as if predicting the wind. It widened when particle density increased, then narrowed again just before the intensity dropped. These weren't reactions, they were anticipations. A growing number of scientists began to treat the tail not as an exhaust, but as a system, one potentially capable of modulation, realignment, or shielding. If the tail was composed of charged particles, as most are, then its behavior should have followed solar magnetic field lines. But this tail bent against them. It curved where it shouldn't and flattened where pressure was highest. One theory gaining traction is that the tail contains more than just gas and dust, that perhaps embedded within it is material capable of reflecting or resisting magnetic influence. That would explain the rigidity. It would also explain the clean edge observed during the reorientation. Then came another signal, this time from Lagrange point L1. NASA's Dioscovia satellite, positioned to monitor solar storms, detected an unusual polarization event directly along the tail's new alignment. A sharp, brief spike in field deviation suggested the tail wasn't just reflecting light, it was interfering with magnetic flux. This opened a disturbing possibility. What if the tail wasn't passive at all? What if it was being used as a shield, as a rudder, as a sensor array, or worse, what if it was a form of communication spreading or catching data as it passed between solar vectors? Whatever the case, one truth was now undeniable. The tail of 3i Atlas was no longer just trailing behind it. It was alive with structure, and it had started to move on its own. In the early hours following the tail's sudden dynamic shifts, most instruments tracking 3i Atlas were focused on motion, magnetism, and visible light. But quietly in the background, thermal sensors began picking up something else, something silent, invisible, and impossible to ignore, a massive spike in temperature. The discovery came not from Earth, but from the James Webb Space Telescope, which had been passively scanning the object's infrared signature across multiple bands. For weeks, 3i Atlas had remained remarkably cold, as expected for a body of its size and distance from any major heat source. Its black body temperature hovered in the safe zone for deep space travelers, low enough to prevent thermal outgassing, steady enough to support structural stability. Then, without warning, the heat signature tripled. Not slowly, not with any observable solar trigger. It happened in a window of just under 20 minutes. What baffled observers was not just the scale of the spike, but its localization. The rise in thermal output came from a single region along the equatorial surface of 3i Atlas, not global, not hemispheric, just a specific strip, perhaps a kilometre wide, glowing hot in the mid-infrared band. This wasn't heating caused by sunlight. The angle didn't match. The sun's rays were striking a different face of the object entirely, and it wasn't caused by friction either. There's simply nothing in that part of space dense enough to generate drag. What this meant uncomfortably was that the heat was either generated internally or focused deliberately. And then came the worst part. It pulsed. The heat didn't just rise and stay high, it oscillated once every 90 seconds for just under an hour. The waveform looked like a signature. Smooth, repeating, unnaturally clean. This wasn't the chaotic thermal noise you get from material venting into space. This was timed heat. Shortly after the spike began, NASA's SOFIA Airborne Infrared Observatory confirmed the same pattern. The aircraft, retrofitted with a massive infrared telescope and flying at altitudes above most of Earth's atmosphere, recorded matching thermal curves, precisely synchronized with James Webb's data, despite being hundreds of thousands of kilometers apart in observational position. And just like the optical pulses from earlier in the day, the thermal spike came to an abrupt stop. It didn't decay, it didn't trail off, it simply ended, flatlining back to the object's prior temperature within 2 minutes. Thermal modelling software struggled to simulate a natural cause. For an interstellar body to heat and cool this rapidly, without mass loss or radiant flare, something else had to be responsible. Either the surface itself had been altered, or an internal system had vented energy in a way we don't yet understand. Some speculated a cryovolcanic event, a release of heated material from beneath the surface. But no evidence of expansion, no gas cloud, and no shadow drift followed the spike. Others pointed to the idea of thermal routing, a concept mostly theoretical until now. In such a scenario, a body could shift internal heat across its surface with magnetic or structural mechanisms, allowing it to radiate excess energy in a focused direction. The implications, if true, were staggering, because only advanced structures, engineered ones, are known to manage thermal dissipation this efficiently. Satellites do it, spacecraft do it, asteroids do not. And still, there it was, a clean thermal spike, pulsing every 90 seconds, ending on its own. Some scientists refused to publish their findings, not out of doubt, but out of discomfort. Because this wasn't just another anomaly. This was thermodynamic control, something that doesn't just survive heat, but uses it. And the closer 3I Atlas drifted toward Earth, the more it behaved not like a rock, but like a machine. By the afternoon of December 11th, an eerie geometry began to unfold, a silent symmetry that only became clear when multiple orbital datasets were overlaid. 3I Atlas was now drifting into perfect alignment with the Earth-Sun line. This wasn't just a casual path, it was a razor-straight vector, positioning the object along a near-flawless trajectory that placed it directly between our planet and the Sun. Not slightly off-center, not drifting nearby, dead center. Solar and planetary alignment happens frequently in orbital mechanics. Planets align, moons cast shadows, comets swing into line with stars as part of their normal motion. But this was different. The alignment wasn't a passive occurrence. It wasn't a momentary passing through a line of light. It was a correction, a gentle but deliberate shift that 3I Atlas appeared to initiate on its own. It had begun several hours earlier. At first, only minor course variations were observed, small angular nudges, almost undetectable. But those micro-adjustments built up. By the time the object reached its current position, telescopes across the globe began to realize what had happened. 3I Atlas had positioned itself along the most critical gravitational line in our neighborhood, the vector connecting Earth to the very star it orbits. This placement is not trivial. The Earth-Sun line represents a zone of maximum photonic flux. It's where gravitational tug and solar radiation create a unique corridor of influence. Satellites use this line for calibration. Spacecraft leverage it for energy absorption, and objects passing through it are often flooded with interference, electromagnetic, gravitational and optical. Yet 3I Atlas didn't seem overwhelmed. It seemed prepared. Its reflective surface, previously erratic, suddenly stabilized. The brightness held steady. The tail, once erratic and dancing across the void, aligned like a directional vector pointing outward from the Sun, extending beyond Earth's orbital plane. And its spectral profile flattened, as if hiding or absorbing the overload of solar interaction. What made this alignment even more unsettling was its timing. Just hours after a thermal spike that defied natural explanation, and immediately following the object's dynamic tail motion and internal pulses, it was now perfectly framed between Earth and the Sun. Observers began questioning whether this was mere coincidence or part of a larger sequence, a choreography invisible until each move had played out. Several scientific teams began modelling the gravitational dynamics, and what they found was quietly published in niche academic circles. For 3I Atlas to achieve this alignment with its current velocity, it would have needed to make a vector correction almost 20 days prior. In other words, this wasn't a reaction. This was planned. If the trajectory had been calculated from outside the solar system, then the object had executed a mid-course correction far before reaching Mars. A maneuver timed to position itself along a line of maximal visibility, optimal energy input, and most direct alignment with Earth's orbital path. This opened new lines of questioning. Why the Earth-Sun line? Was it about visibility, exposure, communication, or was it something deeper, like gravitational synchronization? Space agencies began watching not just the object, but the space between. Because anything positioned perfectly between the Earth and the Sun has a privileged view, and in some cases a strategic one. The implications were now unavoidable. 3i Atlas was not moving randomly. It was responding to forces, and possibly using them. Because in orbital mechanics, alignment is never just about location. It's about timing, control, and intention. And now, the object that once behaved like a rogue comet had aligned itself with the very two bodies that define our life, our planet and our star, not by chance, but by design. Late in the evening of December 11th, the European Space Agency updated a quiet internal document that most people had never heard of. It's called the Orbital Risk Index, a scale used not to predict impact events, but to assess the potential behavior and impact signature of objects passing close to Earth's orbital zone. Not a public bulletin, not a newsworthy alert, just a back-end system that models potential threat vectors for non-terrestrial anomalies, comets, asteroids, and in rare cases, unknown interstellar bodies. On that evening, 3i Atlas was moved up the scale. It wasn't due to mass, or speed, or even orbital deviation. It was something more subtle and more troubling. The object's behavior no longer aligned with the parameters of any standard celestial model. Every observation from the last 24 hours pointed to a fundamental shift, not just in trajectory or temperature, but in pattern recognition. The ESA had begun flagging not what 3i Atlas was, but what it was doing. According to sources close to the agency, the trigger came from three converging anomalies. First, the thermal spike that didn't follow radiative decay curves. Heat had risen and collapsed without a known mechanism. Second, the object's sudden realignment along the Earth-Sun axis, a maneuver requiring exact timing and significant course correction. And third, the behavior of its tail, now shown to be oscillating in geometric patterns not seen in any other known comet or interstellar object. This combination resulted in a rare internal reclassification. ESA raised the object's threat vector score from passive to behaviorally active. That shift sounds abstract, but in practice it changes everything. It means 3i Atlas is no longer being tracked like a comet. It's being tracked like a vehicle. Not one headed directly for Earth, not yet, but one whose choices, if they can be called that, reflect something responsive, something capable of decision points, and in orbital threat analysis, behaviorally active objects are not modelled based on Newtonian motion alone. They are projected across option trees, flows of potential response like moves in a game, and suddenly every telescope and deep space asset in ESA's network was watching it differently. The public didn't see the shift, but internal systems did. The data queues were prioritized, the radar pings became more frequent, observation intervals were halved. New cross-observatory triangulations were triggered with NASA and JAXA. In short, 3i Atlas became a priority object, not because it had grown more dangerous, but because it had become more complex. The term used internally was multivariable asset. That term is normally reserved for spacecraft exhibiting erratic or adaptive maneuvers, like tumbling satellites or malfunctioning probes. Never for a comet, and certainly not for one that came from outside the solar system. But the European Space Agency doesn't make these decisions lightly. They don't elevate the risk profile of an object because it glows brighter. They do it when it stops following rules. One ESA analyst, speaking off record, put it simply, "We don't think it's a weapon, but it's not behaving like a rock, and that's enough." Another noted that the object may simply be passive, responding to forces we don't yet understand. But even that possibility, in their models, requires a new classification, because passive response at this level still implies feedback, and feedback loops imply structure. Whatever the reason, one thing was now clear. The days of calling 3i Atlas a comet were over, and somewhere, deep inside the ESA's orbital threat matrix, a red box quietly lit up next to its name, not for collision, but for control. After the European Space Agency quietly elevated 3i Atlas to behaviourally active status, attention turned to the few instruments capable of resolving its surface structure with any clarity, chief among them, the Hubble Space Telescope. Hubble had already captured dozens of frames of 3i Atlas in prior weeks, offering high-resolution views of the object's surface granularity, tail behaviour, and motion across the solar plane. But none of those earlier images prepared researchers for what it revealed next. On the morning of December 11th, at 3:48 Universal Time, Hubble recorded a series of 6 exposures showing a sharp contrast anomaly, not on the background sky, not within the tail, but on the body of 3i Atlas itself, a shadow. More precisely, a long linear region of darkness stretching across the object's midsection, not soft like a natural terminator line, not curved like a crater rim, but narrow, abrupt, and unnaturally straight. It shouldn't have been there. The sun's angle of illumination hadn't changed, the object's rotation hadn't accelerated. Yet something had appeared. A dark line that split a section of the object's body with geometric precision, and it remained visible for over 42 minutes before gradually dissipating. At first, analysts suspected an imaging artifact. Hubble's cameras, while powerful, are prone to glare artifacts when capturing highly reflective surfaces, but the raw telemetry didn't match any known camera glitch. The shadow moved with the body, indicating that it was a feature on or very near the surface. What added to the mystery was the shape. Under enhancement, the shadow exhibited angular breaks, right angles. This was not the result of a natural ridge or protrusion blocking light. It looked projected, as if something near the surface had intercepted the sunlight in a way that cast a sharp, deliberate line. Several theories emerged within hours. Some suggested a surface panel, either exposed or extending. Others hypothesized a change in material composition, a band of lower albedo across a region of engineered structure. But one possibility made the rounds behind closed doors, that the object had unfolded something even briefly, and that this feature had cast the narrow shadow before retracting or rotating out of view. That theory became harder to ignore when infrared backscatter returned inconsistent results. Data from SOFIA and ground-based sensors showed that the region where the shadow had fallen was not cooler than its surroundings, meaning the shadow wasn't just a cold spot. It was the result of light being actively blocked, and that meant one thing: structure. Whether internal or external, retractable or fixed, something on or near the object's surface had behaved like a shade, capable of occluding light in a clean, sharp pattern. Observers started referring to it unofficially as the veil. The name stuck, because like a veil, it revealed something by covering it, something uncomfortable, something precise. By midday, the images had been circulated among 5 international space agencies. Hubble's data was confirmed by time-matched shadows captured at lower resolution by 2 separate ground-based telescopes in South America and southern Australia. Despite different angles and lower fidelity, both showed an identical streak, same duration, same geometry. The object had cast a shadow, not because of how light hit it, but because of what it did in response. Shadows don't lie. They aren't theory. They're reaction, a body's imprint against light itself. And what 3i Atlas had shown now was more than a reflection. It was a signature, a deliberate absence. After the shadow event spotted by Hubble, researchers were eager to detect follow-up signs of motion, any clue that 3i Atlas had rotated, unfolded, or otherwise reoriented itself in the hours that followed. For that, they turned to a reliable instrument used to track movement in space: Doppler spectroscopy. By analysing the shift in light waves emitted or reflected by an object, scientists can detect whether it's moving toward or away from Earth. This redshift and blueshift principle is foundational to orbital tracking. Every comet, asteroid, spacecraft, or exoplanet ever studied at high speed gives itself away through Doppler signatures. But on the morning of December 11th, something strange happened. The Doppler signal from 3i Atlas went flat. Not faint, not noisy, flat. Across all observed wavelengths, visible, infrared, ultraviolet, the spectral lines that had previously shown motion now held steady. No shift toward the blue, no drift toward the red. Just a locked-in, neutral signature, as if the object had entered a state of perfect equilibrium. This was not expected. Up until that point, 3i Atlas had been exhibiting small, consistent signs of radial motion, subtle wobbles, rotational changes, even slight acceleration events. But suddenly, it was as if it had paused, not in speed, but in relative motion to Earth. From a physics perspective, this is nearly impossible. Nothing in space just locks in its radial motion without external influence. Yet the flat Doppler reading suggested that either the object was no longer approaching or receding from Earth at any measurable speed, or worse, that it was dynamically adjusting to counter its own momentum. Telescopes in Hawaii, Spain, and South Africa all returned the same conclusion. The signal had neutralized. Initially, the assumption was observational error, perhaps a drift in calibration, a solar background effect, or localized atmospheric interference. But those explanations collapsed when orbiting platforms like the Chandra X-ray Observatory and NASA's Deep Space Network confirmed the anomaly. All spectra showed it. 3i Atlas had stopped exhibiting measurable radial velocity, and that left only two real possibilities. The first, the object had matched Earth's motion exactly, entering a temporary synchronized drift, a type of station-keeping behavior commonly seen in geostationary satellites. But 3i Atlas isn't in orbit around Earth. It's not supposed to hold still relative to us. It's an interstellar object on a hyperbolic trajectory, or so we thought. The second possibility, the object was using active compensation, adjusting its velocity continuously to maintain a fixed spectral signature. In essence, it would be mimicking a state of stillness relative to Earth, without actually being still. That theory made waves, because in the natural world only forces like gravity assists drag or rotational friction can slow an object, and none of those apply here. There's no atmospheric drag, no nearby planet to steal speed, no magnetic field strong enough to induce braking. The object wasn't slowing down, it was masking its motion. Some analysts even proposed that the spectral flattening was intentional, perhaps to obscure its true vector, or to shield its approach from standard tracking models. If so, this would require not just reactive control, but predictive adjustment. It would have to anticipate Earth's motion and adjust itself in real time to maintain a neutral signal. That's not something rocks do, it's something systems do. For a moment, Earth's most advanced sensors were looking at a piece of the cosmos and seeing nothing move, a blank Doppler canvas, a stillness so precise it bordered on design. Because in the vast mechanics of space, silence is rare. But neutral silence, that's a message. In the hours following the Doppler shift anomaly, where 3i Atlas effectively vanished from motion tracking, another layer of strangeness emerged. This time, it wasn't a reading, it was an observation. Multiple deep sky facilities, including the Subaru telescope in Hawaii and the VLT in Chile, reported a change in how the object moved across their fields of view. Not in its speed, not in its brightness, but in its behavior through space. It no longer appeared to be flying, it appeared to be gliding. At first, this was difficult to quantify. The object's velocity hadn't changed dramatically. Its tail remained stable, but the way it moved, the feeling of it, was different. Observers noted a kind of smoothness, a frictionless shift that defied the usual erratic twitching seen in cometary bodies or natural fragments. There were no tumbling motions, no lateral jitters, no precession. Instead, 3i Atlas seemed to flow. Like a swimmer moving silently through still water, the object's movement became effortless, direct, clean, and strangely fluid. It didn't adjust or wobble. It didn't correct itself like a rock caught in gravitation. It simply glided. This motion had implications. In physics, gliding implies control without propulsion, motion maintained through lift, surface balance, or drag manipulation. But none of these apply to a vacuum. There's no atmosphere out here to glide through. And yet, the visual data told a different story. Some scientists referred to it as inertial surfing, a poetic term for what was likely a complex relationship between the object's orientation and its gravitational pathway. But the glide was too precise, too intentional. It reminded many of the flight path of controlled satellites, but stretched out to an interstellar scale far beyond the orbit of any known craft. The gliding effect became most apparent when comparing sequential tracking overlays. Between December 10th and 11th, the object's course flattened. not in altitude or direction, but in angular deviation. Tiny corrections that would normally manifest as course drift were now gone. It wasn't just that 3i Atlas had entered a smoother orbit, it's that it had begun to remove the signs of travel altogether. This created a strange effect on long-exposure imagery. Star fields behind the object showed curvature due to Earth's motion, but 3i Atlas remained unnervingly stable, as if the background moved around it, not the other way around. The glide couldn't be explained by momentum alone, the path was too exact. Comets don't glide, they tumble, they jerk, they respond to thermal outbursts, they never maintain clean lateral, translation without evidence of force, and yet that's exactly what was happening. The question became, what mechanism could allow an object with no visible engines, no reaction control jets, and no known form of steering to exhibit such a fluid path? One speculative theory suggested that the object's outer layer could be manipulating solar radiation pressure, subtly redirecting photons like a sail, not to accelerate but to stabilize. That would require not only surface sensitivity but real-time response calibration. Another theory posited internal mass distribution shifting, like a gyroscope with programmable balance. Whatever the explanation, one thing became clear. 3i Atlas was not resisting space, it was using it. Its motion had become a dialogue with the void. No thrusters, no ejections. Just the faint suggestion of a body gliding along a path it had already calculated. As if it wasn't merely passing through the solar system, but reading it. As 3i Atlas continued its impossible glide through the inner solar system, a new silence emerged. Not visual, not thermal, tactile. Because in the vacuum of space, motion still leaves behind a trace, not like wind or water but through the faint electromagnetic and particle trails that every fast-moving body emits. These trails are what astronomers refer to as wake signatures. Even in a frictionless environment, large objects disturb their surroundings, passing through the solar wind, pushing dust, ionizing gas, leaving faint radiation patterns. These are all detectable, and they all form the invisible footprint of an object's movement through space. Until now. Because as of the morning of December 11th, 3i Atlas stopped leaving one. Across multiple instruments, including NASA's Parker Solar Probe, SOHO's coronagraph array, and ground-based magnetometers, the expected wake structure from 3i Atlas had collapsed to zero. No distortion in the solar wind, no ion trail through the heliosphere, no magnetic turbulence in its path, just nothing. This was not normal. Even the smallest asteroids leave some energetic residue as they interact with the solar environment. Radiation pressure alone is enough to create a detectable trail. Yet somehow, 3i Atlas, an object with a body larger than most short-period comets, was now coasting through interplanetary space as if it were non-displacing. It was moving, but not interacting. Initially, teams suspected a data fault. Perhaps one of the solar monitoring systems had gone offline. But after cross-checking data from Japan's Hinode, Europe's solar orbiter, and several amateur radio arrays across Earth, the conclusion became inescapable. 3i Atlas wasn't tripping any of the sensors it should. Not only was its Doppler shift neutral, its magnetic profile flat, and its glide path perfect, but now its wake was gone. The totality of these events began to form a terrifying implication. The object was beginning to decouple from its environment. One researcher described it this way. It's like watching someone run through a snowfield without leaving footprints. A theoretical possibility began to circulate, quietly at first. What if the object had not simply stopped interacting with space, but was actively countering its own wake? That is, what if it had found a way to neutralize the energetic residue it would normally leave behind? This would mean it was not just hiding its signal, it was erasing it in real time. One proposal referenced advanced plasma skin theories, hypothetical technologies that use surrounding charged particles to envelop a craft and smooth its interaction profile, essentially creating a kind of negative echo. These theories are still considered speculative in human engineering, but here was an object doing just that, not in theory, but in motion. It got worse, because in wake analysis the absence of signal is not peace, it's stealth. It's what militaries look for when tracking stealth aircraft, lack of disturbance in expected vectors. And 3i Atlas was now showing the same absence on a cosmic scale. It wasn't just hiding its presence, it was vanishing its trail. Some astronomers compared this behaviour to that of a neutrino, an almost massless particle that slips through the universe without leaving a trace. But 3I Atlas is not a particle. It is enormous, radiant, and very much visible. And yet it was beginning to behave like an idea, not a mass, a thing moving without contact. That idea was not just unsettling, it was revolutionary, because in all of human observation, never had a natural object behave like it wasn't there. And now 3 Atlas wasn't just gliding silently through the solar system, it was ghosting it. Just as astronomers were trying to make sense of the disappearing wake, another anomaly shattered the fragile assumption of stability. In the early hours of December 11th, a coordinated observation campaign between the Very Large Array in New Mexico, the European Space Agency's Gaia telescope, and amateur observatories in Argentina and South Korea picked up something sharp, something that did not belong in the profile of a quiet object, a sudden, precise shift in rotational axis. It wasn't slow, it wasn't chaotic, and it wasn't subtle. The object, up until then showing signs of perfect gliding motion and Doppler neutrality, reoriented itself, and it did so in less than 5 minutes. Astronomers were used to tracking precession and spindrift in interstellar bodies. It's common for comets and asteroids to tumble, especially after thermal venting or gravitational nudges. But this was neither a tumble nor a wobble. This was a controlled realignment, a shift in the orientation of the object's rotational axis by a fixed degree, as if turning toward something. It was like watching a ship adjust its rudder. This shift was tracked by changes in reflected light patterns, specifically a sudden change in the angle of polarization as sunlight bounced off its surface. Ground arrays logged a clear deviation. For a brief window, the object reflected light at a sharper, narrower angle, suggesting a refacing. It was as if the object had turned its face toward Earth. That alone would be remarkable, but the timing made it even more disturbing. The reorientation occurred within 90 minutes of the last recorded wake measurement. It was as if, after ghosting the solar environment, the object had paused and then looked up. The implications flooded in quickly. First, for an axis to shift that fast, internal forces must be involved. Mass redistribution, electromagnetic realignment, or something more advanced. There was no collision, no flare, no visible jet, just a smooth, abrupt pivot, like a satellite adjusting attitude using internal gyros or gravity coupling. Second, this shift stuck. There was no rebound or correction. After the event, the object's new orientation remained locked. Observatories confirmed the new axis alignment for the next 8 hours, and it held steady throughout. And third, this was not a natural response to heat or trajectory. This was a choice. One researcher described it as a gesture, a deliberate act by the object to reposition its mass with respect to its motion, or possibly its observer. Others speculated it might be related to incoming solar wind conditions, perhaps adjusting a sensor or surface in preparation for exposure. But a few noted something else. The new orientation placed a particularly reflective facet of the object, previously hidden, directly in line with Earth-based telescopes. Within minutes of the shift, the overall albedo of the object increased by nearly 20%. It was brighter, sharper, more aware. Was this a calibration event? A navigational correction? Or something more subtle, like the object marking a phase transition in its own behavioural pattern? Nobody knew. But what they did know is this. For the first time, 3I Atlas had broken its passive pattern. It had turned, not tumbled, not twisted, turned, deliberately, as if whatever governed its behaviour had completed one phase and was beginning another. And from this point on, nothing about its trajectory would feel casual. It was no longer drifting, it was directing. After the axis realignment, observers braced for the usual, a fresh jet, maybe a rotational correction, or a shift in the tail. Instead, what followed was quiet, until it wasn't. Roughly 3 hours after the shift, as the object passed through a patch of solar wind near the heliocentric line, something inside 3I Atlas started to glow. Not the coma, not the surface, the core. This wasn't typical thermal radiation, or sunlight reflecting off icy cliffs. What telescopes captured was something else, a faint, deep, concentrated luminescence rising from within the body itself. It began as a low-spectrum bloom, only detectable in the far infrared, but within minutes, the glow crept into the visible band. Soon, ultraviolet detectors picked it up too, forming a multi-spectrum anomaly with no known precedent. At first, some thought it was an imaging artifact, a trick of contrast caused by the tail brightening against a dark solar background. But that explanation collapsed quickly. Multiple sensors, pointed at different vectors, showed the same effect. The interior of 3I Atlas had started to radiate. This was not cometary behavior. In natural bodies, internal light can sometimes leak through translucent ice when backlit by the sun. But this wasn't diffusion. This was emission, controlled, pulsing, centered. The European Southern Observatory was the first to isolate the source, a concentrated cluster near the rotational center, shielded under what had appeared to be a darker surface layer. But now that surface was thinning, not eroding, just dimming, like a lens being peeled away, and under it, something was shining. Spectral breakdown revealed an unusual pattern. Narrowband radiation in the deep orange and near-red wavelengths, laced with short periodic spikes in the ultraviolet. This meant it wasn't just glowing, it was modulating, it had rhythm. Infrared telescopes aboard the James Webb Space Telescope recorded a repeating pulse every 12 minutes, a faint spike, then rest, then another. Not perfect, but consistent enough to imply internal structure, something oscillating or energizing within. The pulses didn't match known comet outgassing patterns. They weren't symmetrical, they weren't thermal spikes, and they weren't responding to sunlight. They were coming from the inside out. This created a new problem. Until this point, most assumed 3I Atlas was a solid or semi-solid mass, maybe porous, maybe fractured, but largely inert apart from its jets and tail. But a glowing core with timed emissions? That suggested compartmentalization. It suggested layers, and possibly even mechanisms. It also shifted the question entirely, from what is it made of to what is it doing. As the glow intensified, light scattering around the coma began to distort. The entire surrounding halo started to carry a faint tint of the same internal colour, like a fog lit from within. It wasn't hot enough to trigger sublimation, but it was enough to change the texture of the light. The tail, too, began to reflect differently. Instead of a dispersed scatter, it began forming streaks, fine, needle-like strands that shimmered under certain angles. Some suggested this meant the internal energy was leaking, gradually interacting with the object's outer shell. Others feared it wasn't leaking at all, it was charging. Because if this internal core had a pattern, a heat signature, a glow, and now a frequency, then this wasn't an inert mass, it was a reactive one, and every pulse seemed to grow more defined, more deliberate, more alive. Whatever 3I Atlas had been before, it was now something else entirely. No longer just an object passing through the solar system, it was a presence, and it had just turned its light on. The glow from within 3I Atlas was still unfolding when something far more human happened. At 4:11 Coordinated Universal Time on December 11th, without warning or explanation, NASA's primary public solar monitoring feed went dark. The stream, normally maintained through a combination of SOHO and SDO imaging relays, froze mid-frame. A blank frame replaced the usual composite of the heliosphere. No new images, no timestamps, no commentary, just a sudden pause in a system designed to never blink. For most casual viewers, it appeared like a glitch, maybe a hardware issue, maybe maintenance. But astronomers and long-time data watchers knew better, because this wasn't just a pause in visuals, it was a cut in all real-time telemetry, light curves, flare alerts, solar wind vectors, all down simultaneously, across multiple platforms. Even the NEOS D-Scover satellite, which shares key radiation and plasma data from Earth's L1 point, stopped updating. That meant two things. First, this wasn't an accident. Second, someone flipped a switch. And then the speculation began. The timing was too close to ignore. The internal core glow of 3I Atlas had been detected less than an hour earlier. Telescopes were lighting up with questions, and analysts were scrambling to make sense of what had just appeared. Then, just as the object began radiating in synchronized pulses, NASA went quiet. Officially, there was no comment, no press release, no placeholder announcement. not even the standard temporary data outage message that usually accompanied maintenance. For almost 47 minutes, the main observational windows into near-Earth solar space were offline, and when the feed returned, it was altered. Gone were the unfiltered full spectrum layers. What replaced them were simplified visuals, capped bandwidth, reduced contrast, and subtle data smoothing across light intensity maps. Viewers noticed it immediately. Some compared it to putting sunglasses over a telescope. The raw feed never returned. Amateur astronomers and solar physicists turned to backup systems, independent observatories, radio telescopes, archived data caches. Many began cross-referencing timestamps, searching for what might have triggered the feed blackout, and one frame kept surfacing. A partial composite, auto-saved by a university in Finland, showed something most viewers had missed. Just before the blackout, a high-contrast flash in the far ultraviolet, spiking directly between 3I Atlas and the Sun. It wasn't solar flare activity, it wasn't a background star, it looked like a pulse, a narrow filament of concentrated light, arcing not outward, but inward, as if being drawn into the object. No official agency has commented on that frame, but after the feeds returned, 3I Atlas was no longer positioned where it had been. It had shifted ever so slightly, enough that newer images showed a slightly reduced angle of tail flare and a tighter coma structure, almost like something had reset. And that's what worried independent researchers the most. Not just that the feed had gone down, not just that NASA hadn't explained it, but that something during those 47 minutes had changed the object, and the world's access to it. From that moment forward, data trickled more slowly. Telescope permissions became more restricted, and a subtle tone shift echoed across the institutions observing it. What had once been a transparent celestial curiosity was now becoming classified. For the first time since 3I Atlas entered view, the space agencies of Earth weren't just watching, they were withholding, and whatever they had seen during those missing frames, they didn't want us to see it too. When the observation feeds resumed and researchers began poring over updated data, something about the structure of 3I Atlas immediately stood out. The tail had narrowed, the coma had compressed, but most importantly a new shape had emerged, something distinct, vertical, and persistent. It was a jet, and not just any jet, but one erupting from the polar axis. Two narrow, opposing streams had become visible, one ejecting upward from the northern pole of the object, and a second trailing downward in perfect mirror symmetry. For the first time since its entry into the inner solar system, 3I Atlas displayed behavior seen only in engineered propulsion systems or highly structured celestial bodies. These weren't chaotic vents, they were aligned emissions. Infrared and ultraviolet filters confirmed it. The shape was narrow, pencil-thin, and projected at consistent angles from the object's poles. The brightness wasn't irregular, and the energy profile was steady. No surging, no flicker, just a constant emission. Observers were stunned. Natural comets do vent material, often from weak points on their surface or from uneven heating. But these jets weren't chaotic or responsive to sunlight. They were perfectly vertical in relation to the object's new axial alignment, the very axis that had mysteriously shifted earlier that day. And just like the glow from the core, these jets didn't come with noise. No tail turbulence, no plasma dispersion, no particulate scattering. They moved cleanly, like thread stitched into the vacuum. The twin polar jets extended far beyond the object's immediate envelope. In long exposure imaging, the jets remained visible even as the background star field shifted. This meant they weren't momentary bursts, but continuous outflows of directed energy or mass. Some speculated this was a stabilization mechanism, like reaction control thrusters keeping the object balanced after its axis shift. Others proposed the jets were not for balance, but for communication. Narrow beams of electromagnetic radiation acting like lighthouses, or scanning pulses aimed towards celestial targets. But a third theory quickly took over, that these jets weren't about the object at all. They were about Earth. The jets had ignited only after the object rotated to face our planet, and once aligned, they stayed fixed, neither chasing the sun nor reorienting with the solar wind. Their direction held, unwavering, as if locked on a specific target. High-resolution arrays in Australia recorded minor wave distortions near the base of the jets, resembling the early stages of field interference, similar to how microwave beams scatter in high-energy lab conditions. The patterns were repeating, not erratic, and they hinted at something more than mechanical. As these jets extended further into visibility, amateur astronomers began stacking images. Across the northern hemisphere, dozens of synchronized frames showed the same truth. These were no random emissions. They were intentional signatures. Each jet fluctuated in amplitude, but never in direction. Their shape didn't broaden or split. And more intriguingly, they seemed to exert a directional pressure, not backward, as if for propulsion, but sideways, like the object was manipulating the very medium of space itself. And this pointed to something far stranger. Because if the object was using jets to steer, not for escape, but for positioning, then it wasn't trying to leave. It was arriving. The polar jets made it clear. 3i Atlas was no longer passive. It was marking its position, holding its axis, and interacting with something beyond the natural forces of cometary drift. Something unseen. Something it had turned toward. And now, it was anchoring itself. In the hours following the detection of the polar jets, another anomaly began to unfold. One not in the object itself, but in its relationship to Earth. Subtle at first, then unmistakable. Ground-based magnetometers across North America and Europe began registering irregular pulses in the upper ionosphere. Nothing strong enough to trigger an alert, no geomagnetic storm warnings, no sudden ionospheric disturbances, but enough to raise questions among researchers who routinely monitored these quiet background fields. At first, it was easy to blame the sun. A minor coronal hole had opened 2 days prior, and the trailing edge of the solar wind stream was still making its way across the heliospheric current sheet. But this pattern didn't match solar behavior. The frequency was off, the amplitude was wrong, and most strangely, the angle was precise. Simultaneously, satellite detectors aboard GOES and the Lagrange Point Station spacecraft began to register a narrow stream of charged particles, mostly low-energy protons and helium nuclei, moving in a path perfectly aligned with Earth's orbital trajectory. And their origin was not the Sun. They were coming from 3i Atlas. For the first time since its observation, the object was emitting a directed stream of particles, a beam, not a spray, facing directly along the heliocentric axis that led straight toward Earth. This wasn't a cloud. This wasn't venting. This was targeted emission. The orientation matched the polar jet alignment almost exactly, except now it carried with it something far more measurable: charged mass. NASA's Deep Space Network tracked the signal geometry. The cone of dispersion from the beam was narrow, less than 1/10 of a degree. In space, that's a thread. And Earth was dead center. The beam didn't fluctuate much. It pulsed lightly, in what some called a whisper. Highly regular low-energy impacts timed across a 4-minute cycle. If this had been a natural outgassing event, the distribution would have been chaotic, fanned out by the solar wind, or at least partially deflected by magnetic shears. But that wasn't happening. The particles were undisturbed. They maintained a stable path from origin to detection, as if sheltered in a corridor or guided along a field line we couldn't see. That puzzled even veteran space weather analysts, because if the beam was narrow, stable, and clean, then 3i Atlas was not just emitting matter, it was aiming it. Further complicating the picture was the chemical composition. Along with standard ions, researchers found trace isotopes rarely seen in natural solar system objects, like helium-3, an isotope more commonly discussed in the context of fusion than comets. Not enough to raise alarms, but enough to raise eyebrows. Back on Earth, the effects remained subtle. No electronic disruption, no radiation spikes. Just a growing sense that Earth had been noticed. It was as if a searchlight had been flipped on, not to blind, but to observe. And whatever 3i Atlas was doing, it wasn't broadcasting randomly into space. It was focusing. Its rotation had locked. Its core had ignited. Its jets had stabilized. And now, its energy, its particles, its signal, was travelling with precision across millions of kilometres of vacuum to intersect a single moving target. Earth. This was no longer the path of a wandering object. This was a line of connection, a bridge, a question. And it left everyone watching with the same quiet realization. This wasn't just something we were looking at, it was something now looking back. As the directed particle stream continued to pulse toward Earth, telescopes across the globe remained locked on 3i Atlas, scanning every detail of its structure. The object had already defied conventional expectations with its symmetrical jets, aligned emissions and eerie axis shift. But what came next was both subtle and deeply unsettling. The texture of the object began to change. What had once been a jagged, irregular shell, pocked with shadows and craters, like any comet or interstellar fragment, was now slowly shifting into a surface that looked designed. The first sign came through reflected light studies. Using a technique known as phase curve analysis, observatories measured how sunlight bounced off the rotating object. Normally, a rough, irregular surface would scatter light in all directions, producing a wide phase curve. But that curve was tightening. Reflective behavior was becoming uniform. Images from Chile's Atacama Desert Observatory showed clear changes in brightness gradients along the object's limb. Over the course of just a few hours, the surface features began to blur, not due to poor resolution, but due to actual smoothing of the outer layer. Shadows that had once appeared in high-contrast ridges and pits were vanishing. The object was becoming even. By midday, the outer skin of 3i Atlas began reflecting light more consistently across its entire visible face. Amateur telescope stacks confirmed it. Surface irregularities that had defined the object's texture for weeks, protrusions, craters, vent-like shapes, had started to fade, and they weren't eroding. They were being absorbed, as if the object was reconfiguring its shell, filling in its own scars. Scientists compared it to phase change materials, substances that shift form in response to heat, radiation, or field exposure. Others went further, suggesting a kind of active morphology, a surface that didn't just respond, but decided. Then came the albedo data. The overall reflectivity rose again, crossing over the 93% threshold, something never before recorded in natural celestial bodies, aside from fresh ice under perfect solar angles. But 3i Atlas wasn't fresh, and it wasn't spinning erratically. It was holding still, facing Earth, while its shell grew smoother, cleaner, more perfect. Radio waves began bouncing off the object more effectively. The returned signals were sharper. This meant fewer disruptions in surface topology, fewer ridges to scatter incoming waves. To some radar systems, it now looked less like a rock and more like a mirror, a giant polished mirror suspended in space, reflecting not just light, but attention. That's when a few researchers began asking the quiet question: why would an interstellar object smooth itself out? Why change form? Why now? Some proposed it was shedding out a debris, heating under solar pressure, losing surface roughness through sublimation. But the timing felt too clean. The process started right after the beam toward Earth stabilized. And not just anywhere on the surface, it was the Earth-facing side that showed the most pronounced changes, almost like it was preparing for something: presentation, reception, or interaction. The eerie symmetry of the polar jets remained. The particle beam stayed locked, and now the body itself was evolving, like a device entering its final configuration after assembly. No one knew how to model this. It didn't match any known physical process. But one fact kept echoing across observatory notes and encrypted emails. The object no longer looked like a visitor. It looked like it had been activated, and Earth was still directly in its line of sight. As the outer layer of 3i, Atlas transformed into a gleaming unified shell, Earth-based observatories and orbital monitors detected something even more perplexing. The object's behavior was now echoing something closer to home. It began with minor fluctuations in Earth's magnetosphere, those invisible magnetic fields that protect our planet from solar radiation. Usually these fields pulse naturally in response to space weather, solar wind, cosmic rays, interplanetary magnetic fields. But what happened on the evening of December 11th didn't fit any natural profile. The pulses weren't chaotic, they were timed. Over a 4-hour window, Earth's magnetosphere began showing a repeating pattern. Low amplitude, consistent duration, and spaced at precise intervals. At first, this could have been a coincidence, but then something clicked. The timing of the pulses matched the emissions coming from 3i Atlas. Perfectly. One beam, one pulse, one ripple in Earth's magnetic field, and then again and again. It was as if the object had found a rhythm, then matched that rhythm with the pulse signature of our planet's electromagnetic envelope, not just influencing it, locking onto it. NASA's magnetometer stations confirmed the correlation. Every time 3i Atlas released its directional particle stream, the Earth's field responded, not strongly, but with a clear synchronized echo. The delay between emission and response matched the speed of light over the object's distance. This meant the signal wasn't just reaching Earth, it was being recognized by the planet itself, or at the very least, by the invisible architecture surrounding it. No known natural object had ever done this. Solar storms batter the magnetosphere all the time, but they overwhelm it. This was different. The energy was too low to cause disturbance, but too precise to be background noise. The implication. 3i Atlas wasn't emitting randomly, it was communicating, or syncing. Some scientists described it as resonance tuning, the way two frequencies slowly align until they vibrate together, like a tuning fork across space. Except in this case, the fork wasn't ringing from Earth, it was being struck from somewhere else. A few fringe theorists began to draw comparisons to Earth's Schumann resonance, a set of natural electromagnetic frequencies trapped between the surface and the ionosphere, frequencies that all life on Earth evolved within, frequencies we rarely think about, but that our nervous systems quietly live inside. And 3i Atlas, it was pulsing right at those same frequencies, not interfering, not damaging, matching. This alarmed more than just scientists. Defense analysts began taking notice. Synchronization with the magnetosphere wasn't just a scientific curiosity, it was a strategic signal. If something can match Earth's magnetic field, it might also be able to manipulate it. And that opens doors no one wanted to imagine. But what struck observers the most was the elegance of it. There was no violence, no force, just quiet alignment, a rhythm across space, converging on a fragile layer of invisible shielding that keeps all life on Earth safe. And now, for the first time in recorded history, an interstellar object had joined that rhythm, not by accident, but by intent. 3i Atlas had synchronized itself with Earth's magnetosphere, and that meant one thing above all: it had found us, not as coordinates, not as a planet, but as a system, alive, oscillating, and now entangled. As researchers continued tracking the strange synchronization between 3i Atlas and Earth's magnetic envelope, attention began shifting towards something more quantifiable: its light. For weeks, observatories had monitored the spectral profile of 3i Atlas, using advanced spectrographs to analyze the composition of its coma, tail, and surrounding energy field. From the beginning, its readings had been unusual: minimal carbon, a narrow ion trail, and strange reflectivity patterns. But now, something fundamental had changed. The spectral lines had split, not fractured, split. It was first noticed by a team in Hawaii conducting long-exposure spectroscopy during the same window when Earth's magnetosphere began pulsing. They expected the usual emission and absorption lines, markers that identify what elements are present, how they're moving, and in what state. But instead of singular lines, their instruments showed dual bands, paired spectral lines, slightly offset, sitting side by side where previously only one had existed. This phenomenon wasn't normal. Spectral splitting in most cases comes from intense magnetic fields, a process called the Zeeman effect. But the magnitude of split seen here didn't correspond with known magnetic behaviors. The deviation wasn't caused by turbulence, nor by rotation. The split was too stable and too even. When teams in Europe and Japan cross-referenced their readings, they confirmed it. Regardless of viewing angle or instrument, the lines were no longer singular. Each key marker now had a companion, faint but consistent, shadowing it, like a mirrored echo across the electromagnetic spectrum. This wasn't noise, it was structure. That's when the hypothesis emerged. The object's signal had bifurcated. It wasn't emitting one spectrum anymore, it was emitting two, as if broadcasting on parallel channels simultaneously. The implications ran deep. In particle physics, dual-state emissions suggest coherence, like a quantum system existing in multiple phases. broadcasting not in randomness, but in layered intent. Some theorized that the object had entered a new operational state, a phase shift, not just in appearance, but in function. The light it reflected and emitted was no longer passive. It now carried patterns, frequencies embedded within frequencies. Some began mapping the harmonic distances between the split lines, discovering repeating mathematical ratios. These weren't just spectral anomalies. They resembled information carriers, like signal encoding, data in light. If 3i Atlas was sending a message, this is how it would begin. Not in words, not in binary, but in structure, in resonance. In the most fundamental language the universe provides, the electromagnetic fingerprint of what it is. But the most unsettling part? One of the two spectral signatures was beginning to match Earth's own optical resonance, a signature eerily similar to how Earth's upper atmosphere reflects certain solar wavelengths. In other words, part of 3i Atlas's emission was starting to resemble us. Not just aligning with Earth's field, not just pointing at our planet, but emitting a light that echoed our own electromagnetic voice. And the other half, it didn't match anything we've catalogued. It wasn't alien in the science fiction sense, it was just unknown. Somewhere between ultraviolet scatter and deep infrared echo, it pulsed gently. A calm, measured beacon paired with the one we recognized. A foreign signal wrapped in something familiar. Together they danced. Two light signatures, now embedded within a single object, synchronized with Earth's field and actively reshaping its outer shell. One side looked outward, the other looked home, and that left a question even the most seasoned observers hesitated to ask. Was this a mirror, or was it a message? As the spectral anomalies deepened and the object's behavior grew increasingly synchronized with Earth's natural fields, one of the quietest but most consequential alerts came not from a telescope, not from a headline, but from a single institution nestled in Cambridge, Massachusetts. The Minor Planet Center, the global hub for celestial tracking and orbital risk, issued an update that, at first glance, seemed routine, a trajectory revision. But beneath the standard formatting and orbital parameters, one detail stood out. Proximity update. Within critical observational threshold. For seasoned astronomers, those words carried weight. It meant that 3i Atlas was no longer just approaching Earth's neighborhood. It had entered a proximity envelope that demanded priority reassessment. This wasn't a vague estimation. This was a reclassification based on new data received over the past 24 hours, triggered by multiple observatories across hemispheres submitting the same urgent correction. The object's relative velocity had decreased, not in a chaotic way, not from gravitational drag. It had slowed down deliberately. Its trajectory was still inbound, but the deceleration wasn't matching any known passive interaction with the Earth-Moon system. The deceleration curve resembled intentional modulation, as if the object were adjusting not just its course, but its arrival. And that raised eyebrows at the highest level. Within minutes of the update, partner institutions were pinged. Infrared observatories were instructed to focus narrowly on the object's thermal wake. Radar arrays were given fresh lock-on coordinates, and satellites orbiting Earth were told to begin passive signal monitoring across non-traditional bands. The urgency wasn't about danger, it was about timing. Because the deceleration meant one thing. 3i Atlas wasn't on a one-way pass. Its path no longer matched a simple hyperbolic trajectory. There were micro-adjustments occurring, tiny nudges that didn't come from Jupiter, didn't come from Earth's pull, and certainly didn't match the random perturbations of solar wind. They were choice points, and the object's proximity update confirmed it had entered what some call a stable insertion corridor, a band of orbital mechanics where velocity, distance, and gravitational equilibrium meet in a delicate balance. Most comets never achieve this. They either crash through the system or slingshot out. But 3i Atlas was doing neither. It was settling. The proximity notice noted that over the last 7 observational windows, the object's course had curved, not sharply but consistently, favouring a spiral pattern. Not a freefall, not a slingshot, a coiled drift, like it was slowly positioning itself into orbital resonance with Earth's motion. This kind of adjustment isn't possible without some form of active correction, and the object wasn't tumbling, it was gliding. Even more disturbing was the way this spiral correlated with the timing of Earth's own magnetic fluctuations, the same ones noticed just hours earlier during the magnetospheric synchronization. The timing was exact. As Earth's field pulsed, the object responded, and as it responded, its path tightened. Like a predator circling or a satellite preparing for stable lock-in. This was not debris. This was navigation. By the afternoon, internal notes within the minor planet center began circulating with a single tag used rarely, and only when absolutely warranted. Observation, priority. Elevated, unknown intent. It wasn't a declaration of threat. It was a recognition that something had shifted. 3i Atlas had crossed a threshold, one that couldn't be explained away by physics alone. Not anymore. It had entered a corridor near Earth, and now it was slowing down, not to leave, not to burn up, but to stay. While orbital scientists were still digesting the minor planet center's quiet but seismic proximity alert, something much more visible unfolded down on Earth, something the public could see with their own eyes. In the upper latitudes of the Northern Hemisphere, just before midnight on December 11th, skies that should have remained quiet suddenly lit up. It wasn't a solar storm. There had been no recent coronal mass ejection, no spike in solar wind, and no geomagnetic conditions forecasted to disturb the Earth's field. Yet the atmosphere began to shimmer with a pulse of light, an auroral flash that appeared without warning and vanished almost as quickly as it arrived. Observers in Norway and parts of Alaska described it as a sheet of emerald and violet, expanding and contracting in place like a breath held and suddenly released. It lasted less than 3 minutes, but in those 3 minutes, magnetometers across multiple countries registered the same thing, a brief surge in localized current, not from space weather, but from something subtler, a magnetic impulse. And when data from these observatories were layered against the tracking logs of 3i Atlas, a perfect temporal overlap merged. Just seconds before the aurora ignited, the object released a new beam of particles, a tight stream, visible in the ultraviolet band, that was aimed not at the sun, but precisely along the Earth-Sun magnetic line, not randomly, deliberately. The auroral burst wasn't a side effect. It was a response. Some speculated it was coincidental, that perhaps Earth had entered a weak stream of residual solar particles from earlier in the month. But those who looked deeper saw the problem. The signature didn't match any known solar source. It wasn't even solar-charged plasma. It was something else entirely. The particles responsible had a different charge to mass ratio, and their spiral into the atmosphere didn't follow the usual arc pattern seen in traditional geomagnetic events. Instead, they descended almost vertically, like data moving through a cable. This was new, and more disturbingly, it only happened once. The auroral pulse didn't repeat the next night. It didn't broaden into a full storm. It didn't evolve into a geomagnetic disturbance. It came, it flashed, and it left behind silence, as if it had announced something, or acknowledged something. Communication satellites in the affected zone reported no signal disruptions. Aviation alerts were not triggered. There were no warnings issued because by all measurable standards, nothing was wrong. And yet something had undeniably happened. For the first time in history, an aurora appeared without solar cause, and it matched the emission window of a deep space object currently entering Earth's orbital domain. A few researchers began referring to it as a direct handshake, the magnetic equivalent of a single blink, exchanged across space and answered by a planet's sky. This was no longer just about the trajectory, it was about interaction. The Earth's upper atmosphere had responded not to a collision, not to an impact, but to a precise magnetoparticle signature sent from an object not even fully within Earth's gravitational well. And the fact that it targeted the Earth-Sun alignment path, a fragile energetic corridor only active during narrow orbital windows, suggested calculation. Knowledge. It wasn't an attack, it was a ping, a test signal, a pulse in the sky that said, "We're here, and we see you." The aurora faded quickly, leaving no damage, but in that brief moment of colour and energy the sky spoke back, and Earth's silence in return felt louder than any signal we've ever sent. In the hours following the silent auroral burst, researchers scrambled to gather every possible data stream from the surrounding space. High-sensitivity instruments, especially those attuned to microparticle detection, were tasked with tracking the one thing that should always follow a celestial object of this size and speed: dust. But nothing came, not a single fragment, not even a grain. Comets, especially those this large and this active, always shed debris. Dust particles trail them like exhaust, forming streams of fine material that can span millions of kilometers. These grains, ejected by heat and outgassing, build the glowing tails we see from Earth, sometimes even causing meteor showers when Earth crosses their paths. But as 3I Atlas approached, even after its proximity drift had been confirmed, the skies around it remained sterile. This wasn't just unexpected, it was impossible. Infrared surveys showed a coma, but it was thin, almost hollow. Ultraviolet imaging revealed jets of energy but no particulate matter. Even Earth-based LiDAR and radar arrays, which are sensitive enough to detect drifting space dust kilometers away, reported no echo. And that triggered a new kind of concern. Was 3I Atlas simply too young to have accumulated dust? That theory collapsed instantly. Its core activity was too advanced, and its reflectivity, already nearing 90%, suggested a surface that had undergone repeated heating and cooling. This wasn't a newborn, it was mature, if not ancient. Then, was it possible that the dust had been shed earlier, and was now trailing far behind? Again, no. Backtracking through orbital data, no dense trail had ever been seen. From its first entry into solar monitoring fields months ago, it had remained dustless. So then the question emerged, one few wanted to ask aloud: what if there had never been dust to begin with? Dust, after all, is a byproduct of fragility, ice sublimating, rock cracking, internal pressure failing. But this object had shown none of that. No fragmentation, no break-off, no erosion. Its jets did not peel off material. They formed without resistance, like precision beams from a solid structure. This realization created a subtle, unspoken shift in how the object was being referred to in closed academic groups. It wasn't just a comet anymore. It wasn't even being called a body in some circles. It was being labelled as a construct, a term deliberately vague. A word used when science doesn't want to say structure or vessel or machine. Just construct. Because a construct can be many things. Geological, natural, even biological. But one thing it's not is chaotic. And that's what dust represents. Entropy, decay, randomness, exposure to heat and radiation. But 3I Atlas had none. The telescopes remained locked in. Still no particulate trail, no reflectivity off fine matter, no particulate bloom in the solar wind. Just one large object gliding closer to Earth, glowing brighter, pulsing more steadily, and leaving no trace of waste in its wake, like a submarine cutting through calm water without a ripple. Even the sun, which often strips material from incoming objects, had failed to scorch anything loose. This thing had passed its solar approach without so much as a scratch, and now it was here, in our skies, dustless, silent, and clean. Whatever it wasn't falling apart. It was holding together too well, and that made it even more unnerving. As the dustless silence of 3I Atlas deepened the mystery, attention turned to the object's core, the region just beneath its shimmering outer shell. Instruments around the world, including those operated by the Very Large Telescope in Chile and the James Webb Space Telescope at Lagrange Point 2, began zeroing in on the light it reflected, not just its brightness, but how that light behaved across wavelengths, and what they found sent a quiet wave of tension through the scientific community. Because the spectral reflectivity profile of 3I Atlas's core wasn't just high, it was uncannily uniform. Natural bodies, especially comets, reflect light in a chaotic mosaic. Ice scatters it one way, silicate rock another. You get jagged spikes and valleys, complex curves that tell stories of composition, layering, and thermal history. But this was different. The reflection curve coming off 3I Atlas was almost flat, echoing a kind of engineered consistency only seen in synthetic surfaces. The kind found in manufactured composites, spacecraft alloys, or engineered reflective panels. It wasn't just bright, it was coated. It held back ultraviolet, bounced infrared with near-total efficiency, and managed to redirect visible light with the kind of behavior observed in multi-layered dielectric mirrors. Technology that humans use in telescopes, lasers, and satellite optics. Even more telling was the absence of absorption lines. Most natural materials absorb light at certain frequencies. It's what gives planets their colours, asteroids their spectral fingerprints. But 3I Atlas's core didn't seem to absorb, it deflected, almost perfectly. And that changed everything, because that meant the surface wasn't just clean, it wasn't just intact, it was designed to be invisible to heat. It was a surface that rejected entropy, and no known comet, asteroid or planetary fragment had ever shown this kind of optical behaviour. The suspicion that had been whispering at the edges of scientific circles now grew louder. A term was spoken more freely in private conversations, in closed-door briefings between agencies: engineered reflectivity. This wasn't a poetic phrase. It was a cold descriptor, a statement of observation. The numbers didn't lie. The reflectivity was too perfect. It had been tested against every known natural substance: carbon-rich composites, metallic ices, frozen ammonia, lunar regolith analogues, even materials from Martian and Venusian meteorites. None of them came close. There was only one category of material that matched the curve, not from space, but from Earth. Specifically, aerospace-grade composites, used in stealth satellites and radiation-hardened optics. That realization rippled outward into speculative domains. Could this object have been coated? Was it hollow? Was it intentionally constructed to shield its thermal signature? And if so, why? This wasn't an idle academic thought. If something, or someone, wanted to move across a star system undetected, reflective insulation would be a necessary feature, not an aesthetic one. The precision was too high for chance. And then came the final clue, subtle, but impossible to ignore. When polarized light was beamed toward 3I Atlas during an observational window, the return signal didn't scatter like it should have. Instead, it produced a structured echo, a mirrored polarization, almost like a signal loop. This didn't match rock. It didn't match ice. It matched layered structure, the kind made of panels, the kind that might peel open, or retract, or unfold. Whatever was inside the object remained hidden, but the surface, the core reflectivity, was no longer a mystery. It was manufactured behavior. And as Earth watched it coast into position, clean, dustless, silent, one question echoed across every lab tracking it. If it was built, who built it? In the hours after the confirmation that 3I Atlas's core reflectivity aligned with synthetic composites, global observatories pivoted toward a new goal: capturing any last-minute thermal or structural changes before the object crossed into Earth's orbital corridor. That's when something stranger happened. At exactly 4 hours past midnight UTC, deep-field thermal monitors aboard the ESA's Solar Sentinel array detected an unusual plume of material rising from the comet's trailing edge. At first, it appeared as a conventional jet, a tightly focused column of particles, likely gas or plasma, streaming out from one fixed point. But then the plume bent, not due to gravity, not from the sun's radiation pressure. It curved perfectly, tracing an arc that began at the object's rear quadrant, swept around the side and completed a full circle, forming a ring. Not a tail, not an outburst. A jet stream ring, closed, stable, and glowing faintly in ultraviolet. This has never been recorded in the history of comet science. Jetting behavior is usually random, chaotic. Ices heat unevenly. Pressure builds up and explodes through fractures. The result is unpredictable venting, irregular and ragged. But this was controlled. The ring didn't dissipate. It didn't flicker or spiral out like a corkscrew. It held for nearly 20 minutes. Telescopes across Hawaii, Chile, and Spain caught the same thing. The same glowing circle, the same elevation above the object's surface, the same fixed velocity in every direction. And then it collapsed. Not like it failed, but like it was shut off. That's when comparisons began. The behavior mimicked a torus-shaped propulsion signature, like what's observed in certain types of magnetic confinement experiments here on Earth, especially in plasma drives and ring-field simulations. But 3I Atlas didn't have an engine, at least not one anyone could see. Still, the signature was there, a glowing arc of ejecta forming a complete symmetrical structure in space, and then terminating with precision. Some called it an anomaly, others called it a demonstration. Because whatever it was, venting, propulsion, a calibration maneuver, it wasn't random. It served a purpose, and that purpose quickly became apparent. As the jet ring dissolved, every major magnetometer within Earth's orbital range recorded a subtle alignment shift, not in Earth's field, but in the Sun-Earth Atlas magnetic geometry. It was as if the object had fired the ring to rebalance itself, not just spatially, but electromagnetically. This would explain the absence of chaos in its movement, the silence in its wake, the dustless glide. 3i Atlas was self-stabilizing, and the jet ring was part of that process. For now, the object coasted onward, no longer glowing, the brief plasma circle gone without residue. But the impression it left behind wasn't so easily erased. People had seen it, sensors had recorded it, and scientists knew exactly what kind of behavior it resembled. Not a comet flaring out, but a mechanism discharging energy in a closed loop, like a device equalizing its field before its final maneuver. Which left only one question. What was the maneuver for? Whatever the purpose, the jet ring was no accident. It was the most structured display 3i Atlas had revealed yet, and it didn't behave like it was meant to disappear into the void. It behaved like it was meant to arrive. The silence from 3i Atlas had become its own kind of language. No dust, no debris, no distortion. And then, almost abruptly, the silence stopped being passive. It started to interfere. Hours after the jet stream formed its ring and vanished without scattering residue, Earth-based radio arrays began to experience something they couldn't explain: intermittent interference, centered precisely on the directional vector of 3i Atlas. It started in Australia. The Parkes Observatory, one of the world's most sensitive deep space listening stations, recorded a series of narrowband disruptions. The frequencies weren't random. They were right inside the window used for planetary radar bouncebacks. Signals beamed toward asteroids and returned to Earth to map surface contours. But now, those returns were being scrambled. For a moment, it seemed like a technical failure. Weather maybe, or solar flare debris. But the sun was calm, and the signal was clean before and after 3i Atlas entered the array's line of sight. That pattern repeated in Spain, where the Madrid Deep Space Communications Complex picked up faint harmonics just above the hydrogen. Again, the interference wasn't static. It wasn't noise, it was structured, phased out, as if the signal was being redirected or reflected in a controlled pattern. Then came the report from Japan. The Yasuda Deep Space Center, operating at high-gain telemetry with multiple Mars-bound craft, noticed a sudden signal drop in the deep dish aimed toward the comet's projected path. Not a blackout, just a dip, like something was absorbing or rerouting the feed. No natural comet has ever done this. Comets can reflect radio waves. Some can scatter them, but they don't jam and they don't modulate. That's when a theory began to circulate, not publicly, but in closed research channels. If 3i Atlas had been silent until now, perhaps this was its only true emission. Not in light, not in heat, but in radio shielding, the kind designed to block observation, the kind designed to cloak movement. Because all the interference followed the same rule. It only occurred when dishes pointed directly at the object, and more specifically, when they tried to beam into it, as if probing for echo data or internal density mapping. And every time, the result was the same. The signal vanished, or bounced wrong, or came back inverted. One array in Greenland even reported a signal looping, bouncing back and forth for milliseconds before fading completely, like it had entered a confined corridor and lost strength. No signal behaved like that unless it was inside a chamber, and if 3i Atlas was interfering this deliberately, it wasn't just shielding its composition, it was shielding its intent. NASA's Jet Propulsion Laboratory issued a quiet advisory to its international partners: hold off on active radar pings toward the object, not out of caution, but to avoid burning bandwidth. Because no one was getting through, and some suspected that the more you tried to look inside, the more the object responded. There was no distortion field, no radio burst, no aggressive flare, just gentle denial, a subtle but unmistakable form of deflection. And that left observers with a chilling thought. Maybe the object wasn't failing to respond to our signals. Maybe it was choosing not to. Or worse, maybe it was listening, and didn't want to be heard in return. After the series of radio interferences left observatories effectively blind to the internal structure of 3i Atlas, attention shifted to the most basic question in orbital mechanics. What was keeping it in motion? Comets and interstellar objects are driven by forces we understand well. gravitational slingshot effects, outgassing vents, solar wind drag. Every trajectory in space has an engine, even if that engine is simply ice turning to vapour under sunlight. But 3i Atlas, it was doing none of that, and yet it moved perfectly. Its orbital path was still adjusting, subtly, precisely, nudging along the plane of Earth's solar inclination, drifting ever closer with no visible force acting upon it. No flare, no vent, no reactive tail. Its coma remained unusually tight, almost dormant. Spectroscopy showed zero gas emissions consistent with carbon dioxide, methane, ammonia, none of the usual volatiles. Even deep cryo compounds, which normally rupture as a comet approaches the sun, remained silent. There was no venting pressure to explain its course corrections, and yet it drifted. More than drifted. It curved. The curvature was the real anomaly. It wasn't passive motion. It was as if the object was piloting itself, adjusting its heading in soft increments, aligning with fields, magnetic, gravitational, or something not yet understood. ESA's trajectory analysts flagged it internally as non-ballistic behaviour. That's the label used when an object no longer moves the way a rock should. Even stranger, its speed didn't spike and didn't fall. It held a nearly constant vector, unbroken by thermal venting or gravitational anomalies. A straight glide with minor, intentional-looking pivots, like a sailboat tacking into the wind, except there was no wind, and no sail. If it wasn't reacting to solar energy, then what was it responding to? One theory gaining traction was that 3i Atlas had internal mass distribution control, the ability to shift density from one end to the other, subtly influencing its orientation without needing jets or gas. It's a principle used in satellites and drones on Earth. But in a comet? That would require a guidance system. The only natural comparison was Oumuamua, the first known interstellar object to visit our solar system, which also displayed non-gravitational acceleration without clear outgassing. But even Oumuamua had its defenders, scientists who insisted it was merely a flattened rock. 3i Atlas had no such cover. Its shape wasn't elongated, its movement wasn't passive, and its silence was now louder than ever. Astronomers began describing it in new terms: responsive drift, intentional silence. These weren't scientific classifications, but they reflected a growing consensus. 3i Atlas was not coasting. It was navigating. Not through engines or explosions, but through field coupling, some invisible alignment with forces yet to be modelled. NASA quietly updated its internal hazard profile. They didn't call it a threat, but they did change the label. From interstellar body to unknown system actor, a term without precedent, because if it was indeed acting without thrust, without gas, without anything visible, then whatever was happening inside that reflective core wasn't chemical. It was controlled, not guessed, not random, calculated. And the closer it came to Earth, the more its movements began to resemble something that shouldn't exist in nature, a decision. After weeks of observation, thermal imaging had painted a clear picture of 3i Atlas. One side hot, the other cold. Just like any typical comet approaching the sun, the side facing solar radiation absorbed energy, while the far side remained cloaked in shadow, frozen, dormant, inert, until that pattern broke. Roughly 6 hours after analysts noticed the object's non-ballistic movement, a subtle shift appeared in the thermal readings from the James Webb Space Telescope. At first it was easy to dismiss, just a 1-degree nudge, a slight uptick on what had always been the cold side, the hemisphere that had remained untouched by solar heating, sealed in icy silence. But then it climbed, not suddenly, not violently, gradually, deliberately. The side of the object that had remained shielded from the sun's rays was now showing a consistent temperature rise, an even spread, symmetrical and smooth, with no hotspots or concentrated flares, no jet, no visible exposure to sunlight, just heat, blooming from the inside out. Thermal analysts couldn't find a solar cause. No solar flare had struck it. No rotation had exposed that face to the sun. The object's orientation hadn't changed since the last vector calibration. It was holding perfectly steady. And yet, it was warming. There was no precedent in cometary science for this behaviour. Cometary ice typically sublimates from external heating, not internal ignition. For the cold side to warm independently, One of two things had to be true. Either something inside 3i Atlas was beginning to activate, or the cold side had never been cold at all. It had only hidden its signal until now. The timing of the thermal bloom raised more questions than it answered. It came just after the object had absorbed or deflected a volley of directed radio probes from Earth, and only hours after the now infamous jet ring had stabilized and dissipated. Everything appeared to be building up to something. Some scientists proposed exotic materials, hyperconductive alloys or artificial insulators embedded beneath the surface, now reaching a threshold and releasing stored energy. Others were more cautious. They didn't see a thermal reaction. They saw a gesture, a quiet reply to the pressure Earth had been placing on it. Pinging, scanning, trying to decode its shape, its spin, its purpose. Maybe this was its way of acknowledging us. Whatever the reason, the warm-up pattern was too clean to be natural. It spread in bands, concentric waves rippling outward from a central point beneath the surface. Not chaotic like fractured vents, not explosive like spontaneous outgassing, but timed, sequenced, like a machine powering up. The signal wasn't strong enough to emit radiation or trigger alarms, but it was unmistakably artificial in tone, as if the object had been waiting, hibernating, and something had finally flipped the switch. It didn't roar to life, it didn't spiral out of control, it just began to stir, quietly, confidently. From deep within that mirrored core, heat began to pass through layers we still couldn't penetrate with radar. It rose through material we couldn't classify. It wrapped itself around the cold side like a second skin, until, by all thermal standards, the object was now uniformly warm. The cold side was gone. It had been replaced by an active, stabilized, fully awakened shell. And once the temperature hit equilibrium, something else occurred, something small but deeply unsettling. The object stopped rotating, fully, perfectly, as if it had now become directional, facing Earth, fixed, waiting. The final signal wasn't an explosion, it wasn't a collision, it wasn't even a sound, it was nothing. At precisely 0411 UTC, all motion readings from 3i Atlas, thermal, rotational and spectral, flatlined. Not gradually, not decaying over time, instantly. The object, which had been heating from within, adjusting its course with eerie precision, interfering with Earth-based radio dishes and displaying behavior more suited to a spacecraft than a comet, simply stopped. It didn't crash. It didn't veer off. It didn't react to solar wind or gravitational nudges from nearby planetary bodies. It became still. The rotation that had governed its axis for weeks, clocked at a slow but measurable rate, halted to zero within less than a second. This wasn't a slowdown, it was a shutdown. The type of behavior engineers refer to as intentional damping, a kind of controlled stop that requires active systems. Naturally tumbling objects don't do this. Even spacecraft struggle to do it with that level of smoothness. And yet, here was 3i Atlas. Silent, motionless, suspended in solar space as if someone had pressed pause. The reflectivity readings stayed high. Thermal emissions held steady. But every form of movement, the slight drifting, the minute pivots, even the subtle response to Earth's gravitational lensing, was gone. In its place, a strange kind of stasis, almost like it had entered a dormant mode, now fully aligned with Earth, holding position with mechanical elegance. Not a comet in decay, but an object that had completed its maneuver and no longer needed to move. The Minor Planet Center updated their log. No anomaly, no emergency. Just a curious footnote. All observable motion has ceased. Object now in static lock. No warning, no interpretation, just a cold confirmation that one of the most active interstellar objects ever observed had now become a fixed point. Not drifting, not responding, not accelerating, just waiting. Telescopes kept watching, of course, and radio dishes kept listening. But the interference that had plagued them before was gone. Signals now passed straight through the object's line of sight with no disruption, as if it was no longer trying to block anything, as if it had opened itself but offered no further message. Infrared readings showed no continued warming. The internal temperature remained perfectly level. Whatever process had initiated from the cold side had run its course. The object was no longer building towards something, It had arrived. At what, no one knew. Theories proliferated. Some suggested it was observing, some said it was recording, others proposed it was waiting for a signal, some external trigger that hadn't come yet, or perhaps had already been sent. But the most unsettling theory came from those who studied planetary defense behaviors, that 3I Atlas had not stopped out of exhaustion. It had stopped because it had completed its approach, like a probe locking into orbit, like a sentinel placing itself into alignment, and now it simply held there, facing Earth, quiet, intentional, frozen not by nature but by choice. And so, for the first time since its detection, there was no new data, no new heat, no new spin, just a line of silence stretching from deep space to the blue planet it now faced. Not moving, not reacting, not gone, just there, watching.